Hello, welcome back to Learn Physics. In today's topic, we are discussing about light, reflection and refraction. So it's a revision topic. We did all the theory portion in detail in previous classes, previous videos it's there. So everything is there in the playlist. So the playlist itself I'll be giving in the description box. If you have any doubt, you can watch that also. And this is a revision for your CBSE exam, that is within half an hour. I will try to say all the important concepts. Okay, so these concepts you should know, and after that only we can start our question papers. Okay, revision for question papers we can start then. So today is the next chapter, light, reflection and refraction. So I think the previous two videos about the electricity and magnetism, magnetic effects of electric current, those two videos are useful for you, and today is light, reflection and refraction. Okay, so here first we are going to study about the reflection of light. Okay, here we are considering first about the plane mirror. Plane mirror, what are the properties of image formed by a plane mirror? So what are the properties or characteristic of image formed by a plane mirror? They are, it's virtual one, it will be virtual, first it will be virtual, then it is laterally inverted, and third one, it is of same size, and fourth one, the image distance. If this is the position of mirror and this is the image distance, and this is the object distance will be same as the image distance. Object distance from the mirror will be equal to the image distance. So these are the properties of or characteristics of the image formed by a plane mirror. It will be virtual, it will be laterally inverted, and it is of same size that of the object. Image size will be same as that of the object, and next one is distance from the object to the mirror will be equal to the distance from image to the mirror. Okay, so these are the characteristic properties of a plane mirror. Okay, next we study about the spherical mirrors. There are mainly two types of spherical mirror we are studying. First one is convex mirror and the second one is concave mirror. Okay, before studying about the convex and concave mirror, we should study about the spherical mirrors. Spherical mirrors are the mirrors which is a part of a sphere. From the sphere, we are taking out a part. Then that is a spherical mirror. Spherical mirror is the mirror which is taken out from the part of a sphere. Okay, in that one side will be reflecting surface and the other side will be non-reflecting surface. So spherical mirrors will be, see, if this is a part of sphere, okay, if this is a part of sphere which I am considering, and the inside part is reflecting and outside part is non-reflecting. Non-reflecting part we will be marking like that. Okay, so if the inside part is reflecting and the outside part is not reflecting, that means reflecting surface is bent inwards, then we can say it is a concave mirror. Reflecting surface is curved inwards, then we can say it is a concave mirror. And if I am considering, if this is a sphere and I am taking a reflecting surface like this, okay, the reflecting surface is bent outwards. If the reflecting surface is bent outwards, then we can say it is convex mirror. If the reflecting surface is cave inside, then it is called a concave. If the reflecting surface is bend outwards, then it is convex mirror. Okay, so by considering these two mirrors, for a spherical mirror, some general terms you should know. Okay, so the center of the sphere from which we had taken out the spheres, the center of the sphere in which we had taken out the mirror, that center is called as center of curvature. C is called a center of curvature. Okay, the center of the sphere from which the mirror forms the part, that is called a center of curvature. Center of the spherical mirror, the center of the spherical mirror, that is called a pole. It is represented by P. Okay, center of the spherical mirror, that is called a pole, P. Okay, now the straight line which is passing through the center of curvature and pole, that is called a principal axis. So if I am representing it as AB, this AB is called as principal axis. This imaginary straight line which is passing through the center of curvature and pole is called a principal axis. Principal axis. Okay, next, center of curvature to pole. This distance is called as radius of curvature. Center of curvature to pole, CP. This distance is called as radius of curvature. Radius of curvature. Okay, next term you should know is aperture. Aperture is the diameter of the spherical reflecting surface. Okay, this diameter of this spherical reflecting surface is called as aperture. If I am representing it as DE, this DE is called as aperture, or the spherical surface. What is this distance? This is called as aperture, where we are getting reflection. That surface is called as aperture. Okay, so it is aperture. Aperture is the diameter of the reflecting surface, that is called a aperture. Okay, so these important points you should know. C, center of curvature, center of the sphere in which mirror forms a part. Center of the mirror is called as pole, and the distance between pole and center of curvature is called a radius of curvature. Okay, and then the distance from the diameter of the perpendicular distance, if I am considering the diameter of the reflecting surface, is called as aperture. Okay, and next we are going to study about what will be the principal focus of a concave mirror and a convex mirror. Okay, principal focus. So for a convex and concave mirror, the principal focus will be different. So if I am drawing like this, which kind of mirror is this? It's a concave mirror, curved inwards, cave. So it is concave mirror. For the concave mirror, this is the principal axis. This is pole and this is center of curvature. While you are drawing, you should take the compass, keep it at the center of curvature, draw an arc. Okay, then you can mark this as C. Okay, this is center of curvature. Now, if the rays which are passing parallel to the principal axis, the rays which are passing parallel to the principal axis after reflection will converge to a point on the principal axis. That point is called as principal focus of a concave concave mirror. The rays which are passing parallel to the principal axis after reflection will converge, will come and join at the principal focus. That point is called as principal focus. So the statement is, the rays which are passing parallel to the principal axis after reflection will converge to one point on the principal axis. That point is called the principal focus. And one more thing, don't forget to put the arrows. In principal axis, don't put the arrow. If you are putting the arrow in the principal axis, it's not an issue. Through that also light ray will pass. Okay, if you are drawing considering that as a principal axis only, then don't put the arrow. Okay, and next, if it is putting the arrow over here, it will go undeviated only. It is not an issue. Okay, so while drawing the diagram, that will be well and good if you are drawing another two parallel rays. Okay, the rays which are passing parallel to the principal axis after reflection. Parallel rays means, why is it parallel? Because it is coming from very far distance. That is, if the rays are considered to come from incidenting from infinity. From infinity, if the rays are coming, we will consider that as a parallel rays. Okay, so the rays which are coming parallel to the principal axis after reflection will converge to point. So since that is converging to a point, these mirrors are otherwise called as converging mirror. Okay, so next is for a convex mirror. Okay, for a convex mirror. Convex means bent outwards. Which is bending outwards? Reflecting surface. Reflecting surfaces bent outwards. So this is the principal axis, this is P, and here will be the center of curvature. Okay, it is curved like this, right? So center of curvature will be here. The rays which are passing parallel to the principal axis, what will happen? Will appear to diverge from a point on the principal axis. We can see if I am considering this as from one, it will reflect and go like this. Okay, so if I am drawing on graph, see, this is the principal axis parallel and it will go like this. Okay, and here these two rays, if I am considering, this will be coming and reflecting at this point. Okay, if I am extending the reflected ray and it will meet at one point. So actually those reflected rays are not meeting. Okay, we are trying to make it coincide at one point on the non-reflecting side. Okay, so that is called the principal focus of a convex mirror. The rays which are passing parallel to the principal axis towards a convex mirror after reflection will appear to diverge from the point. It has appeared to diverge from the point on the principal focus. That point is called as the principal focus of a convex mirror. The rays which are passing parallel to the principal axis after reflection will appear to diverge from a point on the principal axis. That point is called as principal focus of a convex mirror. Since it is diverging from one point, it is otherwise called as diverging mirror. Okay, so this one, while you are seeing the picture, you will feel it is easy. Yeah, this one I know. But usually children will get confused while coming here in which way it should diverge. Okay, so it will be diverging above. So in which way, simply will it be going like in whichever way it wants? No, it has some laws to obey. This how the light ray after reflection, how the light ray should go. For that, laws are there. So next is laws of reflection. Okay, laws of reflection. What are the laws of reflection? There are two laws for reflection: the incident ray, reflected ray, and the normal at reflected ray and the normal at the point of incidence lie on the same plane. Okay, the incident ray, reflected ray and the normal should lie on the same plane. That is the first law, and the second one is angle of incidence is equal to angle of reflection. That is second one. So there are two laws of reflection, the incident ray, reflected ray and the normal at the point of incidence should lie on the same plane. That is first law. Second law is angle of incidence is equal to angle of reflection. So these are the two laws in the case of reflection. Okay, so clear what is principal focus of a convex and concave mirror and the laws of reflection. Now next is what is meant by focal length. Focal length is so if I am calculating this focal length, it will be coming here. Okay, so focal length is focal length is the distance from principal focus to P. So this FP distance is called as FP. This distance is called as focal length from principal focus to pole. From pole to principal focus, what is that distance? That distance from pole of the mirror to principal focus is called as focal length. From pole to principal focus, that is called a focal length. Okay, so focal length is the distance from pole to principal focus. Okay, this distance is called as focal length. Okay, so now we learned about the radius of curvature and principal focus. There is a connection between radius of curvature and principal focus or focal length. What is the relation connecting radius of curvature and focal length F? Capital letter F for principal focus and small letter F for focal length. Okay, focal length. Next is connection between R and F. R equals 2F. This is the formula. Okay, so while you are drawing the diagram also, you should consider it will be exactly at half of C and P. Suppose you are taking it as 4, exactly at 2 centimeter, you should mark the principal focus. So the formula is R is equal to 2F. Okay, so next we are going to study about the image formation. Okay, next is image formation in spherical mirrors. Image formation in spherical mirrors. Okay, how we can find out the position of image? There are 3 rules to find out the position of image. Okay, so in the case of a concave mirror, first I am going to consider the concave mirror. Okay, so this is the concave mirror, this one pole, this is center, exactly half of that principal focus. The rays which are passing parallel to the principal axis, after reflection it will go through the principal focus. Second one, if I am considering this as concave mirror P and this is C and exactly half of this F, then the rays which are passing parallel to the principal axis, how it will be going? Principal focus. Next we should consider the next rule, the rays which are passing through the principal focus, after reflection it will go parallel to the principal axis. This is the second law. Then third one is the rays which are passing through the center of curvature, it will go undeviated. Okay, it will be reflecting through the center of curvature itself. That's why I told in the previous session, I told you if you are sending a ray through the principal axis also, it will be reflecting back. So if you are giving like this, it will come back like this only. The rays which are passing parallel through the center of curvature, it will be retracing its path. Okay, so and one more thing, angle of incidence is equal to angle of reflection. In that manner you can draw. Okay, these are the main three rules to draw to find out the position of image. Okay, so different positions of object, we will be finding out the position of image. Okay, so clear. So parallel, focus, through focus, parallel, through center of curvature, retracing its path. Next we are going to consider about the convex mirror. Okay, convex mirror means this is a convex mirror. Here this is P and this is C and the rest half of it is F. Okay, so here the rays which are passing parallel to the principal axis, after refraction it will go diverge and go. After reflection it will diverge from a point on the principal focus. Okay, from the principal focus it will diverge and go. If the ray is passing parallel to the principal axis, it will appear to diverge from the principal focus. Okay, so while you are drawing, first if you are drawing the divergent ray and then if you are trying to focus on the principal focus, it won't be proper. So while you are drawing, what you can do, see here you will be marking F initially itself, isn't it? Just half of PC you will be marking it as F. Why? Because it is R is equal to 2F. Then while you are drawing, you can keep your scale here. From here to here you can keep the scale like this. Then from here to here it is dotted lines and from here you can draw the continuous line. Then you will get a nice picture. Okay, otherwise it will be confusing for you, and afterwards without a straight line you should try to join like that. It will look dirty. Better than that, you can do like this. Anyway, you know, if it is passing parallel, it will appear to diverge from principal focus, right? So you can keep the scale over here and put the dotted line still here and then draw the continuous line. Okay, so the next one is here, this is P and this is C and half of it we will be marking it as F. The rays which are which are appear to incident through the principal focus. So that means we are feeling the ray is coming towards the principal focus. Then after reflection it will be going parallel to the principal axis. Okay, appear to come towards the principal focus. After reflection it will be going parallel to the principal axis. So the same way here also you should use the same method. Keep the scale till here, then draw the continuous line till here, after that dotted lines. After reflection, parallel lines. Clear? Now it is here everything is all the rays won't be coming till the P, F and S. See, why? Because it is a divergent ray. So the rays which appear to come through the center of curvature. So you can keep the scale over here and then after this you can draw the continuous line. Which appear to come towards the center of curvature. After reflection it will retrace its path. Okay, so these are the three rules for a concave mirror and a convex mirror to find out the position of image. Okay, clear? So now we will try to draw one or two image formation, how we will be finding out the position of image. So in detail everything is given in the description box. All the respective videos I already did. Okay, and this is a revision, just a quick revision of all these portions. So if you are knowing all those things, it will be easy for you to understand the concept. Okay, clear? Next, first in the case of concave mirror. Concave mirror, if the object is beyond C. Okay, I am considering in that way. This is a concave mirror. This is the principal axis. First you should put P and center of curvature where you are putting your compass and drawing the line, and exactly half of that you can consider it as F, or position of object is, this is the center of curvature and beyond C. So this is the object. Mark that also. Now raise any two rule which I told this in the previous session, that one we can use. I am taking the ray which is passing parallel. After reflection will be passing through the principal focus. Okay, so that is one rule. The next one, the ray which is passing through the center of curvature or principal focus, any one you can consider. So the ray which is passing through the principal focus, incidenting here, after reflection it will go parallel to the principal axis. So these two rays where it is meeting, reflected rays where it is meeting. This is the reflected ray and this is another reflected ray. So it is meeting at this point, right? So this will be the position of image. Okay, clear? This is the position of two reflected rays should meet to get an image. Two reflected rays should meet to get an image. Always remember that with one line you can't find out the position of image. Okay, so clear? So this is which kind of image it is? It is an inverted image. So nature is, this is the inverted image and it is smaller in size. So it is diminished image, since actually these two rays are meeting at one point, right? So we can say it is real, inverted, then it is diminished one. What is the position between F and C? Okay, clear? So now I will show you how to find out a virtual image in the case of a concave mirror. So if I am keeping the object between F and P. Okay, so here I am taking a concave mirror. This is the position of P, F, and one more time this is C. Okay, simply if you are drawing in all the cases you won't get, so please use the this compass and pencil, scale, everything to get a good position of image. So on the board it is difficult for me to use a small scale. I don't have a big scale with me and a big protractor where in schools that you are using. Okay, so that's why I am using this one. Okay, not protractor, compass. So if the object is between F and P, this is the position of object. We can consider any two rules, right? So if the ray is passing parallel to the principal axis, after reflection it will be passing through the principal focus. And then if the ray which is passing through the appear to incident through, if it is incidenting through the principal focus, so it should touch, see, it should touch the object, then only we will be getting an image. So if I am taking a ray which is passing through the principal focus like this, whether it is touching the object, it's not touching the object, right? So we should consider a ray which is touching the object. So I am considering a ray which is passing through the center of curvature. Okay, then if I am considering a ray like this, it will incident and retrace. Okay, so here I can see that these two rays are going like this. It's not meeting anywhere. So, but these two are non-parallel lines, right? So if I am extending this and if I am extending this, I can see that on the other side, behind the mirror, it is meeting at one point. So it is not actually meeting. They are going it as non-parallel lines. So it's not actually meeting at one point. We are making it to meet at one point behind the mirror. So we are getting an image. We only did that thing to meet the point. Meeting point we only found out, isn't it? It's not actually meeting. So it will be a virtual image. Virtual means it will be erect also. So here it's actually meeting, so we will be getting real and inverted image. Here it is not actually meeting, we made it to meet at one point, so it is a virtual and erect image. So here it is enlarged image behind the mirror. Position is behind the mirror. Okay, so clear? This is how we will be finding out the virtual image. It is if the object is between F and P, and at F, if we are keeping the object, then also we will be getting a virtual image in the case of a concave mirror. Okay, next is for a convex mirror. Okay, convex mirror between F and P, between P and infinity, at any position we are keeping, we will be getting a virtual image. All the positions, if from infinity or if it is between infinity and P, any point, we will be getting a virtual image. So see here, this is a it is a convex mirror, and this is P and this is C, and if it is F, I am keeping an object over here. Okay, the ray which is passing parallel will appear to diverge from the principal focus, isn't it? So the ray which is appear to come through the center of curvature. Like this. It will retrace its path. So it is meeting at one point over here, right? So this is the meeting point, but there it is not actually meeting. We only made it to meet at point with the dotted lines. That is after if it is coming, the reflected rays or meeting position is at the reflecting side itself, then it is the actual meeting. Otherwise it is not the actual meeting. So this is the position of the image. So it is a virtual image, always behind the mirror. All the virtual images will be behind the mirror. Okay, clear? So these are about the image formation. Now we should study about the mirror formula, mirror equation. Next we are going to find out the mirror formula. What is mirror formula? It's very important. 1 by F equals 1 by U plus 1 by V. This is mirror formula. Here U is object distance, V is image distance. That is distance, object distance from means from pole to position of object, from pole to position of image. That is image distance. Object distance is from pole to object, that is object distance. Next, magnification. Magnification means whether it is enlarged or diminished. How we can find out? It is given by the formula minus V by U, or M is the ratio of height of image to height of object. So these equations are important, very important equations. 1 by F equals 1 by U plus 1 by V. M is equal to minus V by U. M is equal to HI by HO. Okay, these formulas are very, very important. And while doing these formulas, we need sign convention. That is very important thing in the case of these formulas. See here, sign convention. If this is the position of mirror, okay, mirror only we are marking the pole, isn't it? So pole we will in the graph, what is the position of origin? That is the position, that is the importance of pole here. Okay, so pole you can consider like a origin. So mirror that is origin. Pole will be considered as origin. So measurement always we will take from origin, right? So from pole we will take the measurements. Towards right side it is positive, towards left side it is negative. If it is upwards it is positive. Here also upwards we will consider positive, and downwards we will consider it as negative. This one it should be in your mind. Pole is like an origin. Clear? Now, so in the case of a convex mirror, if I am considering convex mirror, where will be the position of focus? Focus is in this side, right? This is pole. So focus is towards right side. So in the case of a convex mirror, focal length will always be positive. In the case of a concave mirror, if I am considering, we know it is on the left side. So focal length will be negative for a concave mirror. Okay, focal length is positive for a convex mirror, focal length is negative for a concave mirror. And my request is, please don't try to by heart the things. Understand and write down. Otherwise positive negative will be confusion for you. See how I am doing. So if you are asking to me in between or it's in a sudden way, I will think in this way and will say the answer. Okay, if you are trying to by heart the thing without understanding, you will forget sure. So better convex, you can understand towards right side, so it is positive. Concave, it is towards left side, it is negative. The same way, real and virtual images. Object is like this and you will be getting a real image like this. So Hi by Ho is the formula for magnification, isn't it? So if you are getting an inverted image, this is negative and this is positive. So inverted means if it is real image, magnification will be negative. Okay, for virtual image, both will be upward or both will be downward direction. So magnification will be positive. Okay, so this is the things which you should understand in the case of mirrors, and that is for reflection. Next is, what are the uses of reflection of or convex mirror and concave mirror? Uses of concave mirrors. Concave mirror, it will be used in dentist mirrors and shaving mirrors, and then we will be using it in torch, searchlights, and it is used in solar cooker. In solar cooker, reflection, it's from sun rays, parallel, after reflection, principal focus. So all the light ray will be incidenting on the principal focus, and there will be the position of the food to be cooked. Okay, so that is in solar cooker. So dentist mirrors to observe the images, enlarged images, they will be using concave mirrors. Shaving mirrors also, because of the enlargement of each object, they are using as shaving mirrors. Torch and searchlight, the position of in torch, position of the bulb will be at the principal focus. From principal focus, if the light ray is incidenting, what will happen? It will be going parallelly. So it will be from large distance. For large distance use, we can use this method. So it is used in torch and searchlights. And next, in solar cooker, I already told you, it will be focusing just opposite to this one. Incidenting parallelly will be converging at the principal focus. Okay, so this is about the solar cooker. Next is for a convex mirror. Convex mirror is used as a rear view mirror. Rear view mirrors. Why it is used as a rear view mirrors? But the image will be diminished. Far objects also we will be coming it as a, it's saying as a, it's very close to us. so it is helpful while we are driving. Okay, and it is rear view mirrors and vehicles we are using because it will be a wide area we can observe in the small mirror. Okay, so that is the use of this rear view mirrors as convex mirrors is used as rear view mirrors. Okay, and in parking space also you can see this convex mirrors in big apartments or in malls and all. We will be seeing this convex mirrors. So the uses and the reason for that also you should learn. Okay, clear? I hope it's a little bit lengthy because of since I thought I will explain also a little bit more, so it's lengthy. Otherwise you can finish, if you know the things, you can finish within half an hour itself. Okay, I hope it is clear for you and you should do it very well and understand the things, and in shortly I'll be coming with the question papers. Okay, be ready for that. I hope all of you understood all those things, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.